that wonderful introduction. I love the idea of being introduced by students. It's a great honor that we have to go and find this information about me and put it together. So thanks so much. It's wonderful to be back. This is actually my first time in this room in 10 years. And it's a little, I mean, deja vu and everything, but I'm less intimidated, I must say. Everything seems smaller. When I was here, kind of like when you're in grade school and you go in and the chairs are huge, and now I come back to this normal space. So it's great to have such a big crowd. So Sarah invited me to her JDP, Joint Degree Program, to give a talk. And I thought, well, it's fun to go to Princeton, but it's really fun to be invited for a lecture series. So I'm not invited to do the Tanner lectures or something like that. But this is the second in a series of lectures. And a few of you were here yesterday to hear about using names as a way to understand immigrant assimilation. And today I'm going to present the next chapter in that project, which is using names as a measure of how parents think about their children and fertility. That's the context here. And here I have, so this is a little bit in honor of Viviana, who calls books things like this, naming the precious child, pricing the priceless child. And this is me, okay? Carl Mason, he's kind of our Herman / he's like our Herman at Berkeley, so he's in the background. And here I have my intellectual grandchild, one of my graduate students' children, and her only child named Arden. And there's another graduate student that they know is going to have more children, and she named her child something less hard to remember than Arden. The idea. So what we're going to be looking at is how names reflect the parents' parental intentions about building a family, and we're going to be looking at this over a historical time for periods that we have names of people and lots of characteristics of people and families. So in the U.S. in the 19th and early 20th century, and we'll be using this as a way to, as if we interviewed people. I'll go into this in a little more detail. To figure out how many children they wanted and how much they wanted to invest in their children. This kind of indicator of that. So that's why it's the quantity-quality trade-off. And I should say that I am. We all have to leave at 1, but I'm very happy to have discussion during the talk. If you want something clarified, or if you violently disagree, go ahead, raise your hand. I'm happy to. At least I'll know you're listening. Okay, and then this is joint work with my co-author on all of this work, Guy Stacklov at Hebrew University. Oh, and I put MPC April 2016, but this is a new talk. This is a revised. This is for OPR. Oh, it is for OPR. And we'll start off with a story here. This is a kid's story, Tiki Tiki Tembo. A long time ago in old Japan, when a mother loved a little boy very, very much, she gave him a long, long name. And when she did not love the little boy very much, she gave him hardly any name at all. Once there was a mother who had 2 little boys. One she loved very, very much. And so she called him Tiki Tiki Tembo, no Sara, no Hari, etc., which means everything nice. So this idea that you name your child based upon how much you love him is not a new idea at all. In fertility theory, we have kind of 2 theories to oversimplify of the demographic transition. So I think a lot of people in this room just did kind of their first year demography courses or recently did this, and we have kind of 2 schools of thought on why people began to invest more in their children and have fewer children. One is that the world changed and people adapted. So I'm calling these the adaptationists, and of course economists love this. People responding to changing prices and incentives. And then we have the more sociological perspective, which was actually developed largely at Princeton by people with PhDs in economics, like Leslie Cole, which is that fertility control was an innovation, it was a new way of thinking, and that this kind of new idea spread. And so the actual spread of fertility control and people's practice of fertility limitation was not because things suddenly changed or circumstances changed. It was because maybe they changed long before, but the new idea then emerged. Okay? And sociologists love this idea, and this is really not in this room, but across the street and maybe down the road a little bit, these ideas were developed. And this is the kind of evidence that was used. This is a map of the timing of fertility control in Europe by Princeton's own Ansley Cole and then Princeton's Susan Watkins. And it's showing that fertility decline happened in France along national borders, okay, before 1830, and then it kind of spread outwards, and the darker the color, the later. So it looks like a contagion spreading outwards. And then they argue, okay, this looks like a social process of contagion, but of course economic development or something like that could also be spreading the same way, and then the whole Princeton Fertility Project is about showing that, guess what, the standard predictors don't fit as well as we want them to with people's behavior, and therefore there's some kind of superstructural process, something ideational or sociological going on. Okay? So, of course it would be great to know what people were actually thinking. And so Etienne Vanderwaal, what was he at Princeton before he went to Penn? Was he visitor? He was a visitor at Princeton before he went to Penn. In his PhD presidential address, he had kind of a dream. Okay? So his dream was, wouldn't it be great to have a survey taken in 1800 England or 1750 France in which women were asked, if you could start your life all over again, how many children would you like to have? If we could only do kind of our standard fertility preferences survey in the past, then we could unpack what was going on. And that's what, in fact, we will do today. We will ask women how many children they want to have in the past, even though we can't meet them. Well, they're answering the question. They're giving us the answer even though we didn't pose the question. So, how are we going to think about this? The name given to a child is going to be. How should we think about this? So, I guess we have deep, in-depth interviews. Right? You go and you embed yourself in some place. You can do deep research. Well, here we're going to get qualitative information. It's going to be very, very thin. Okay? So we're going to ask, instead of doing an in-depth interview, we're going to ask an interviewer to say, what does your child mean to you? And they're just going to give us a one-word answer. Not very informative. We could have talked to them for hours and done focus groups and all this kind of thing. We just got one word. And the advantage we're going to have is it's going to be very thin. Let's see, math here. Thin data, is that I think this is thin data spread really, really widely. So we have lots of it. We have millions of answers to this question. But we only have one word. So we're going to make sense of it. And the idea is we're going to, if we can crack the code, if we know what the words mean, then we'll be able to make sense of the answers the parents are giving us, even though they're only telling us one word. Which they can tell us about their intent and how many children they want to have and how much they want to invest in this. Is that okay? People? Okay. It turns out the methods that we developed here, when I talked to my colleague Ken Walker, he said, those are the exact same methods we use in genetics. It's called polygenic scoring. So this is it's actually the same method that are already being used in the kind of big data world already for other things. Polygenic scoring, does that mean anything to anybody? So the people were saying that genetics determine how long you stay in school use polygenic scoring. They don't know which gene it is, but they take your whole genome and they predict it. Okay. So what are we going to do? We're not going to decide between the innovationists and the adaptationists. We're just going to try to answer three questions. The first one is, does this work? Do names predict what's going to happen? And by predict, we mean if you know the name of the first child, do you know how many children they're going to be and how much education they get? There's not the first order. We're going to leave that out. It's too complicated. We're just going to say at the and this is also kind of the simplest way to think about the world. This is kind of Gary Becker saying you decide on your quantity preferences. You have quantity preferences early on, and you make an initial decision. It's a one-time decision. It's not a dynamic thing where you update. You just make your initial decision, and that has some influence. The second thing we're going to do, that's going to be on family size. I mean by that how many children there will be. And then we're going to ask, well, is this consistent with what's happening at the same time to quality. So in that case, it'll just be schooling. And then the third, which is going to try to get at the original question I raised, is when did this all begin? Have parents always been doing this, and they did this kind of throughout the demographic transition, or was it not happening and it suddenly started happening? So, here's what I'm going to do. I'm going to start out with the kind of way we got into this work by reading a blog. But not a blog about names. And then I'll show you a methodology. I'll show some detail for 1900, and then we'll kind of briefly show the results across the whole period. And then, if we have time, I'll do fashion. So it turns out stable population theory is useful for understanding fashion. Do that. It's a little advertisement, and we'll finish up. Okay. So here's how we got. Oh, sorry. Before I show the picture. So how did I get started on this? I read Andrew Gelman's blog, and he said something like, oh, there's something so cool in this other names thing, and it's that the concentration of the names has gone way down. It used to be that the top 20 names were half of the people, and now the top 20 names are only 10% of the people. And they have all kinds of theoretical problems with the, oh, fertility decline. Now people have few kids, so they could give these special names. And I thought, well, okay, well, the world's also warmer. I mean, there's 2 points. It could be temperature. It could be 1,000 things. Okay? And then I suddenly realized, oh, wait a second. Fertility has not declined monotonically over the last century. It went down, and then it went up, and it went down. So then I made this plot. What happened to the concentration of names? Well, it goes down, and it goes up, and then it goes down. Don't even worry about what this says. Just believe me that it goes down. Here I'm showing different. You can measure this in different ways. The top 5 names, this is 100%. So we see. So the top 10 names for girls were 25% in 1880 and 5% today, something like that. There's lots of interesting things here, but this is kind of the motivation. Okay, we've demonstrated that the reason names have changed is because fertility changed. Well, that's not.
That's the men went straight down.
Sorry?
The 5'10" men they didn't move up.
These didn't go up?
No, they did everything. They went straight down.
There's some interesting stuff happening here at the end. Which I think is a major question. I don't have time to talk about what's happening at the end. It's very interesting. Yeah. So then it's like, well, this is cute and everything, but maybe we now at the micro level have a way to see how much people value their children. So let's not just see if this works at the micro level, let's try to use it as kind of leverage to make some intellectual progress. Okay. So questions about picture? I mean, there's a interesting difference between girls and boys. There are interesting differences here at the end. This is U.S. This is U.S. data. This is for all children born in the U.S. because, it's somewhat, the nature of this data changes. There's certain tax laws that are passed, so you don't get it on your taxes unless your kid has a Social Security number. Big incentive to get a Social Security number in the hospital. It's more automatic. And so there's some issues like that. These are I don't know how they actually even do place of birth. So for immigrants, some of this detail you might want to ask questions about. And of course, we have census data, which is what we're going to use here, so you can compare the census data in the cross section to this, which is cohort data. Yeah.
So the first half of the data is all sort of survivor bias because you lived long enough to get.
Yes,
right?
exactly.
Those three different opinions.
Yes.
You guys need
Yes.
survivors.
And I had a student do a paper, names predict mortality too. In the same, it's kind of the same names that predict high investment and low fertility predict high survivorship.
Now that would be a baby naming book you could publish.
There you go. It's not the name, okay? So even though we're working with names, I'm going to say the word names. These talks are not about names. They're just using names to study something else. So when I give this talk, people either hate it because what am I doing, wasting my time studying names, or they love it because I'm using names to study something they're interested in. So I hope you're in the latter. Okay, so let's go to the micro level. So we're going to use censuses from IPUMS. I think we're using the public data, although now the 100% data is available to those who work hard to get it. We didn't go up to 1940, but now we could. Our family size, demographers should hate this. I kind of hated it the first time I heard someone use this. But we just have children in the household. So fertility is going to be children in the household. It has some pros and cons. It's what we have. The one thing that we, in 1900, and I'm not sure, at least in 1900 and another year, they asked the children ever born and children surviving questions, so you can redo the analysis with children ever born, and you can see it doesn't change anything. So that's reassuring. So there are definitely children missing, but they're not missing in such ways that they change the qualitative features of the analysis. They change the numbers a little bit. And then, of course, it's number of surviving children depends on the age of the mom, because if you're 18, you just can't have that many surviving children. If you're 38, you can't, and you're just later in life. So it involves some issues about whether we're controlling properly for whether how we model this. But I would love to get comments on that. Actually, we just did something ad hoc, and people may have better ideas. Can people hear me? We're only going to deal with the native-born. We're only going to deal with white parents. We're only going to deal with moms aged 35 to 44, so that we minimize a little bit the problems with this number of survivors. So everybody's had a chance to have kids. Not too many kids have left the household. If we did moms age 50 or something, that would be a problem. So we kind of chose this group here as a compromise to get enough samples, to have our samples be big enough, and to be dealing with a population that number of surviving children would give us an indicator of what total fertility, fertility children ever born were for the family. Okay, and then we use the name of only the firstborn, because there's definitely a birth order effect, and also we want the causal ordering to be right. We want this to be kind of people's intentions at the beginning of their lives, because we think that's what is easiest to think about. Okay, and then preciousness. This is, of course, I'm sure when you saw the title of the well, how do you know what the precious name is? We're not going to define that in advance. We're going to let the data tell us what names are precious. So let's see. Now we'll look at. We'll just go to the results. Done. Okay. We'll start at the end here. This is also kind of the beginning. So what is this? This is showing us the average number of children in the household and the child's name. This is in 1900. So this is for this particular graph, I did a complete census because I wanted to get very little uncertainty about the scores. So these are the uncertainty bars. If you do it with the sample census, you're going to do fine running regression things, but each name is going to have a lot of uncertainty attached to it, so you can't really make much sense of this picture. So let's just take an example. Harold, a name of kings, right? Harold is a name of kings. Family size is very small. Here's frequency. So frequency is a good. This is. You might say, well, things don't depend on frequency. Good. That's, I think, a good thing. We're not just picking up commonness of a name. There's something more to it. And also frequency just helps me spread things out. I have to have some Y variable to get the labels unduplicated. Okay?
Josh, was there a tendency, and did this change over time, of parents to name their firstborn after themselves? And would that, if that changes over time, then that may be a little wrench.
Well, there certainly is. That's certainly changing over time. That's part of what's going on. But I don't consider that a wrench. I consider that a hammer, and a positive thing, because if you're naming your child, presumably in a traditional family, this may be a high fertility family, is going to have a rule for naming their child. And naming the child after the father, I would think of as kind of a rule-based decision as opposed to an individual investment in the child. So the fact that people would change those rules is actually the kind of phenomenon that we're picking up. So you may disagree with my interpretation, but there's a lot going on here. Same thing, people switching from biblical to non-biblical names. In some sense, that's a change in religiosity, but it's also a change in, am I going to give my child a unique individual name that has a particular meaning?
Well, I'm just putting it in the context of what you said when I walked in. I'm sorry, it kept me in the meeting. But if you're trying to measure fertility intentions, you don't know whether you're going to have 5. If you know you're going to have 5, you may restrict your name to the third rather than the first. And that's
So what we're arguing is that people did know they were going to have. They were planning on having a lot of children. They were planning to have few children. They were planning to invest. That's our kind of our working hypothesis.
Right.
And you're going to become convinced of that, maybe or maybe not, from what I'm
all right.
doing.
Convince me.
Okay. So Harold and Kenneth are very precious names. I'll call them that. And Jesse and Charlie and Grover and Joe and Samuel and okay. So you kind of get a sense of what's going on. I mean, when you look at these are the kind of names that are in novels at the turn of the century. Henry James, F. Scott Fitzgerald, these kind of names, and these are the names that are not so much. There's other things going on here, and I added a little color to show you. The red names are names ending in IE, kind of nicknames. So it works. IE is not the effect, because Leslie is not a nickname, so it's a valuable name. But the nicknames are all high fertility names. And then kind of our Scrabble theory. You only get so many letters. So if you're going to have few kids, you use long names. If you have lots of kids, you use short names. Here I've done long names, which I guess is 7 or 8 letters, and so you get to see that the blue names tend to be low fertility names. The long names tend to be low fertility names. There's different features. So we wouldn't have to, I mean, one can kind of look at this and imagine, okay, I can figure out a system for doing valuable names based on number of letters, based on whether it's a nickname, all this kind of stuff. Okay. But that's a lot of work. And we have thousands and thousands and thousands of names. So what we're going to do is something much simpler, and I'll explain that in a minute. Let's just look at the girls. These are girls, same kind of picture. Marion, Dorothy, Mildred, Bernice, Gladys. Now, some of these names that we think are very not. Today they have a different meaning to us, but you have to put yourself back in 19. This is the census of 1930, so these children are maybe born in 1920 or so. So these are flapper names or something like that. Yes. Thank you.
To what extent, you might answer this later, and if you do, just tell me to wait. But as I'm looking at this, I feel like a lot of what we're seeing is differences in social class.
Yes.
Is that okay?
Absolutely.
Yeah.
Well, I again, I'll do the hammer and the wrench. Okay, the wrench is if it's just an artifact of social class. The hammer is if it's the aspiration for social class, and we're going to argue that this is kind of an aspirational thing because we're going to control for what we observe in social class. Yeah. What else do we see here? We see that for the girls, the long names are all to the left. Okay, and we also see that the red names are. Okay, these are just some top names. There's thousands and thousands of names. Okay. Mary. Here's Mary up here. Mary is basically a surprisingly neutral name. The dash line is kind of the average.
It's also like the only biblical name, almost the only biblical name in the girls. We also have Ruth. There are far more biblical names on the high fertility side of the males.
Of the men, yeah.
Yeah, they're
And
not.
here's Sarah. Again, this is 19. These are babies.
They're more on the boy side.
Yeah, I mean, the other reason I think you don't want to get into too much of the features of these names is that every era has a different set of features that are magical, and so it's not really. You want something more automatic. Okay, so what are we going to do? We're going to use our standard kind of big data machine learning approach. We're going to try to control for all the noise, because some of this is signal and some of this is noise, right? Here the standard errors are small, but still some of it's just random. That it happened that the people in the census that year had big families. And then how are we going to deal with this confounding issue that Maggie brought up? Well, we're going to have our multivariate controls from the census, occupation, things like that, and our great killer weapon is going to be all the cultural variation and religious variation. We're going to use last names. So we're actually going to show you fixed effects models within the O'Donnells or within the Goldsteins. Okay. So how does this work? We're going to split our sample. So I'll make that picture. Let's see, the training is the green. So I'll make a picture with half the sample, that name pyramid, and then those scores that I got for the names, those are going to be the scores that I'm going to assign for the names. And then I'm going to do a bunch of regressions later on. That's going to be my test, where I'm going to take those scores, and if they predict fertility in the set-aside group, which is half the sample, then I wasn't picking up noise, I was picking up signal. So I have one head really nodding. Should I walk through this? Let's see. Split my sample in two. On my training sample, I'm going to estimate the fertility scores. It's going to be the average family size. Then you can either control for things in setting this. You can do the conditional scores, controlling for things, or not. We've done it both ways. I'm not sure exactly what I'm going to show you today. And then you assign those fertility name scores, I think we call it F score or something like that, from the training to the test data. And then we use the test data to regress on fertility. And first of all, we find that it matters in the test data, so we're not just picking up noise. And second of all, that we can start adding controls to see if it's the name that matters or the things that are correlated with the name that we can partial out. Okay, and I think our idea here, getting at Maggie's question, is we're thinking of otherwise similar parents differ in their utility function for quantity and quality, and that's what we're seeing here. That's the way we're thinking of this. So these are people who are otherwise, the thought experiment is people who are exactly like in every way, except they have different preferences. That's a nothing exactly like different preferences, but I mean structurally, income, education, where they live, or their last name. The question? Yeah. Please? Did I use decision trees? I think I have to say I don't know the answer because I don't know what you're being asked. Is that okay? We can talk about it later? Okay. I mean, sometimes there's just no, I'm not even going to try because I don't know quite what you're asking. Sorry. Okay, so let's see what happens here. This is a nice procedure because we have these big data sets and we're writing statistical code, and we know what the coefficient should be on the training data. The coefficient on the training data, since we estimated these scores to predict family size, they should perfectly predict family size in the sense that the coefficient should be 1. So that's something very nice. I've never done a project where we have kind of a unit test on the code that always tells us whether we made mistakes. And sometimes we ran the code and we didn't get 1 on the training, and we knew there was a mistake, which is very nice because we wouldn't have known otherwise. Okay, so the first thing you see is that there's no bug in the first part of the code. That's what we can confirm here. Okay, so here we only have 12,000 people. I'm not quite sure why we have so few. We're working on a sample. We've restricted it to a lot of restrictions here. Okay. Let me say one more thing about this R squared, because I think I can do this wrench and hammer thing here. Okay. So, do we want a big R squared or do we want a small R squared? Well, first of all, I can make the R squared higher by increasing my sample size, because then I just have less noise on each estimate. So the R squared is a little bit arbitrary. But I think this small R squared is actually pretty neat, because everybody's going to want to talk about their personal experience with names. And I'm going to tell you, your N is too small. You need 10, 20,000 people in order to even see this effect. And you can barely see it even with 12,000 people. So this is the kind of insight, and I'm saying because this is a weak effect, that's too bad. It's not super important. But on the other hand, it's the kind of thing that we only see when we're doing analysis at the population level. Your individual experience will not tell you this. It's only at the aggregate that you'll see this. So that's fine. You see Matt looking skeptically. Okay, so when we do this on the test data, it turns out that about, and I don't want to talk about half, but the coefficient is half its size, and then what that exactly means, one can debate. But it's. I think that in this case, we don't really want to look at the coefficient itself. We want to look at the stars. Usually, it's the other way around, right? Ignore the stars. That's what Obama said about ISIS. That's the JV team looking at the stars. Instead, we should look at the coefficient size. But here, I can make the coefficients bigger or smaller just by increasing sample size. So the actual coefficient doesn't, I don't think, mean too much. So really, it's whether it is a significant predictor in like test data. So it's really that's what. So the stars are really what are meaningful. However, the relative coefficients is probably interesting. So I think we don't really want to pay attention to this as half of this. But now let's see what happens when we control for things. So when we control for urban, rural, and age of the eldest child, which turns out to be very important, and region, which turns out to be very important, then that's a lot of what's going on. People in urban and rural places are getting different names, they're having different fertility. It's not that, that parents are that farmers are choosing to have smaller big families or city dwellers are choosing to have smaller big families. It's that there's different cultural practices in those two places, and there's different family sizes in those two places. Okay? And then when we add this class dimension, now what is happening here? This number should be over here. Oops. Okay. So I told you I was giving a different talk in Minnesota. I didn't talk this So, okay, it's positive. It's negative. Good. It's negative, which is what we want, because in 1900 the fertility transition is taking place more among rich people than poor people. So we're getting the right sign. Other questions about this? Probably just the type of yes.
Yeah. So it seems like the argument you were making at the beginning is there's this idea inside of people's heads. We want to know that the thing that we observe is the name, and then we want to infer what's inside of people's heads from the name.
Okay.
So do these numbers somehow tell us about the strength of this association?
What do you mean by strength?
I mean, like if you have an indicator for some underlying construct, and you want to know that that's a good indicator for the construct that you have.
Well, it tells us about the actual scores I calculated and how predictive they are.
Okay. So
but I think I can make them arbitrarily. I can make them quite a bit more predictive by increasing sample size. So I don't think much of what you're seeing is artifacts of the fact that my scores are constructed on a small sample. I don't think we know. This is a lower bound for how much you're able to predict. And it's a very low bound. So the name itself is only doing 1% of the explaining thing. But the things like age and rural urban are doing 30-40%. So this is not. I don't think this is not an important predictor in the sense that if you know someone's name, you know a lot about how many siblings they have. But it's a clearly visible predictor in the sense that when our samples get big enough, we see it clearly, and it's not just an accident. Yes?
I'm going to defend you better than you do.
Please. I'll take a drink.
The difference between your last two columns does say name matters. So, yes, your third column says, no, there really are, there are regional cultural differences that make a big difference. But now we've controlled for that, now let's do income, which is, of course, the next really big thing. And we want to see that coefficient of name just go down to nothing.
Yes, and it doesn't change at all.
It's exactly.
I mean, it must go down a little bit in some mechanical sense. I don't know why it doesn't actually go down here. That's a different sample. You see that we've lost some people. But it's essentially the same. It goes down undetectably.
But
You mean the 26 and the 25?
Sample size, but if you increase sample size, you'll change the stars.
No, but right here, so, I mean, it's strange that we control for income and the effect of the name actually increases by 0.01. But first of all, that's insignificant change. But second of all, this is a slightly different. I've lost, because I'm including income and I don't have income for some people, I've gone from 12,000 to 11,000. So they're not, this is not a coding error that the coefficient went up, whereas if it was the same sample, I would say, this is strange. I'm controlling for something in the coefficient. It should be going down a tiny bit. Okay, yes?
So I think you were just raising a question that we're also confused by. Why does the bigger sample, it'll buy you more stars or it'll make things significant, but why is it buying you change in the size of the coefficients, the R squared, those other things? Why is sample size doing that to you?
Because when I get these scores from the first stage, some of the reason Kenneth is a low fertility name is because Kenneth really is a low fertility name. But some of the reason I think Kenneth is a low fertility name is because it happens to be the lowest one, just the people in my sample. I don't know anything about Kenneth. All I know is the people who named their kids Kenneth had small families. So imagine that we have a tiny. Let's just do the sample. We both have. Two children or 2 children? Two. Sorry. Okay. So the name of your first child is Ian?
Yes, good.
Okay, go ahead. Ian. And the name of my first child is Susanna. Okay, so with a sample of 2, now Ian should be 2 and Susanna should be 3. Now the predicted value of that when I go to this population is not going to be very high. That's because that was just a chance effect. But now let's say I had 1,000 Ians and 1,000 Susannas. Then I would get then you would expect in my and I get the scores from the 1,000 and then I go to the population. Well, then I'm going to be quite accurate.
I would say your standard errors go down an awful lot, but I'm not sure your coefficient expected value.
It turns out that it is the actual. I can make these coefficients go up and down but proportionally by. I mean, we can go into deeper. I don't think that's.
Can I just clarify? So, just to be clear, when you're saying pre-samples, you mean in the training set, right?
Yes.
Because I think that's what explains
Yes.
Noreen's point.
Yes.
It's like increasing in the test set.
No, it has no effect.
Your errors
Yes.
expectation. But
Thank
increasing
you.
the training set.
The
you're
audience
changing
is
the
better
weight.
than the speaker. Right? Okay. Thank you. Yes, that's very good point. Excellent. Okay. So now I want to finish in about 10 minutes. So I'm not going to get into modeling education now. I'm just going to show you some descriptive findings. It turns out the fertility score, these are now the family size scores, are highly correlated with whether with the proportion of people in school. I'm forgetting exactly what this is. I think this is the proportion of girls in school ages 12 to 18 or something. So it's kind of an age at which you might or might not be in school. So we did that for boys and girls. And the Florences, 80% of them are in school, and the Lizzies and Lilies, only 50% of them are in school. And the same thing with the boys. The Elmers and the Herberts and the Rays, which are low fertility scores, are much more likely to be in school than the Samuels and the Thomases and the Alberts. And I apologize for these are slightly differently calculated name scores.
I'm just trying to understand why there's so few names. Are you using regularization? What's the design?
Because I'm only showing you like the top something names so that I don't have just a cloud of something. So these are just the top names.
If there's a name in the actual data set that wasn't in the training set, do they get dropped because you don't give no information for them?
Then they get dropped, yes. Yeah. Yes.
Since these are coming from the census forms, do you think it's possible that when the census takers went around, they said, who's in your family, and someone said Lizzie, but that person's name was actually Elizabeth?
Yes, absolutely. I don't think these people, what is somebody's true name? I don't know. Is it a birth certificate? Is it what you tell the census taker? Is it what your census taker transcribes? So we had a big discussion of this yesterday with the immigrant names, because it's the same issue. And there's definitely a class aspect to this, right? If you say, my daughter's name is Lizzie, and I'm Dr. Professor Goldstein, maybe the census taker writes down Elizabeth. There's that kind of thing.
Have you looked at names like William or Elizabeth and seen if the variation of nicknames has any power?
We're taking them all as they are, but I also we have not gone back and asked whether Willie is the same as William, but I think the answer is no. And a lot of that is a social class. I mean, that's not necessarily the parents thinking at the moment they have the child. It's hard to say that they named them the nickname because they probably didn't, but it might reflect in a slightly different way parents' feelings about their children, the meaning of their children. But it's probably largely a class thing. And what you say to the census taker. You may call your child Willie at home, but you know when the census taker comes, you tell the census taker William. Well, that's a certain kind of, you can imagine that's very class structured. What kind of behavior is appropriate for your family, how do you want to represent your family. Yes.
You never talk about what you tell the census taker.
Yeah.
About a quarter of these names come with middle initials, which you're not doing anything with, which I think is also a pretty strong signal of something, potentially.
Yes.
Like whether you report
So that's a great idea. We got rid of the middle names because it was too complicated, but simply a dummy, whether you reported a middle name or whether it was a middle initial, is a neat idea. On the other hand, we're trying to say these are not just reporting issues at the census. These are things at the onset when the first child is onto the family building. So we're not primarily interested in the artifacts produced by census reporting, but it's a great.
But it's the signal of what the person is saying.
Easy to do.
As much as it lives with the person.
Easy to do. Good suggestion. Okay. So what happens over time here? So this is where the sample size thing came into consideration. Because we had when we first ran this analysis, we got a completely different set of results because the sample sizes are different for these different censuses. And then we realized, oh wait, if we're going to compare coefficients over time, we want to have the same sample size. So I forget what's the smallest sample. What have I been showing to date? 1900? Yeah. So I think we must have kind of matched things up to 1900 because 0.025 looks like the right number. And then, for example, 1880, there's a complete sample for, so 1880 sample is much bigger. So now these are all normalized, standardized in size, and what happens? Okay, highly predictive in 1850, but matters very little. Okay, what does that mean? That means people are aware of fertility. People have intentions, but they are not very predictive. Okay, and there's a mixture here. The size of this coefficient, depends on the correlation between x and y, the standard deviation of x, and the standard deviation of y. So comparing data, it could be any of those things that are changing over time. But let's not get deep into that. Let's just look at the general argument, which is that guess what? In the middle of the demographic transition, there's lots of variation, and whether you're a small family person or a big family person, actually ends up making quite a bit of difference. Whether the name makes quite a bit of difference in the middle of the demographic transition, and when everybody has big families, it doesn't make much of a difference, and when everybody has small families, it also doesn't make much of a difference. So this part we have to work on a little more. It has to be decomposed, I think, a little bit, why these coefficients are changing, but that's the basic idea. So our 2 points here are that there's intentionality all through this period. We couldn't go before 1850 because it doesn't ask children's names before 1850. But as early as we can go, we find intentionality, and then it follows the kind of pattern that we would want to see, which is that when there's a lot of action in terms of individual decision making about family size and whether you're going to go big or small, that's when we see names mattering a lot. This is, I think, the part of I'd like to get feedback on this. It's complicated to think about. So,
did you take into account last names for this?
Good question. I think this is probably that last model of income.
Okay, so you didn't do within last name.
Right, but one could.
And there's been a big change in rural urban, but you control for rural.
Yes, these are the with controls, but I should be able to tell you exactly which controls these are. But having a co-author is great.
Was the name scores were constructed separately for each of these?
Yes.
Okay. So Sally moved over time. But
yeah, so a little bit the kind of methodological puzzle we're confronted with is that you can only, your variation in name scores depends on how much variation there is in family size. So the standardization of name scores, it kind of depends on how much variation there is in family size, but so that's the x variable. And then the y variable is the variation in family size. So according to that kind of argument, the relationship of the numerator and the denominator should be constant over time, and so what's changing is the correlation coefficient. So this is showing the correlation coefficient. But the other part of it is, we're still, I have to sit down with her mom or something. Okay. So let me get to our stable population part, because this is kind of fun. Okay, so we did fashion. We said the trendy names, those are the ones that lead to small families, and the old-fashioned names lead to big families. Okay, so old-fashioned names are names that are going out of style, that have negative. This is the growth rate in the fraction of the population, the fraction of the cohort that gets the name. So the new names, the trendy names, are Donald and Harold and Cecil and Raymond. It's like out of some kind of Worcester. What's the guy's name? Jeeves and Worcester. This 1920s kind of burn. Yeah, these kind of modern names here. These are kind of like the Princeton class of 1920s. And then Jacob and Frank and Fred. These are all going out of fashion. And look, the names that are going out of fashion have high fertility. The names that are new have low fertility. Okay, but this is home of formal demography. So what's going on here? What's going on here is that when there's negative population growth, the population is older. And therefore, by our measure, you have more siblings when you're older, because you have more chance to have kids. If you're a new name, you're very likely to be young. You don't have a chance. You're the oldest child, whatever. You don't have a chance to have fewer kids. So you always thought the stable population theory was for the birds, but here you can actually do, name analysis. So this just goes to show that you don't. This graph is misleading because it does the raw fertility score. You want to adjust for the age of the oldest child when you take care of the problem. Right? Okay? And I didn't do that graph, but the effect is much smaller when we adjust for the age. That's still there. So that's what I said here. You don't control for the age of. So that's okay. So let's just talk about what fashion means, and I'll finish up. Okay, so how are we thinking of what's going on? Let's take that earlier slide as the truth that the new names are the fashionable ones in small families, because it's true to a lesser extent, but it's still true. I showed. Okay, so I think what's happening is that you have kind of this cutting wave of people. And so hipsterism was cutting wave when I last gave this talk, which was 6 months ago, but it's probably yesterday's fashion now, so I'm probably already out of fashion. But you're a new person, you're a modern person, you're forward-looking, you're an early adopter, you're whatever you are. And part of doing this is you're doing what's new and modern, which is having small families and investing a lot in your children. Part of what it's doing is you're giving out that signal that you're new and modern, you're giving the child a name. You may not, there's no conscious thing. If I name this child, I'm giving them a high-value name. You're aspirational in terms of the social meaning and your status. Okay? So one of the things that was cutting edge was to have fewer children invest in them. And you don't need the self-conscious naming practices. You just desire to be part of something, a certain, Bourdieu, habitus, I think it's the same idea here. You kind of striving to have a certain social signification or meaning for your family and yourself. And it's not that you're strategizing. In the case of the immigrants, the parents were probably strategizing to some extent. But here, you're not thinking about, I'm going to give my kid a high-class name. No, you give your kid a name that sounds right to you because that's what you want to be. You may not even know. You may not have seen this impulses before you give your name. Okay, so we're going to finish up. So methodologically, I think we argue that we have this text data, that names, in fact, do tell us something about fertility and understanding parents' intentions, that we can just use these kind of off-the-shelf methods, test training methods to get rid of the statistical problem, which is the noise, and get at the signal. And this is, I think, an approach, especially because we can do this automatically. You just give me the data set, or you can do it yourself. You've got the recipe here. You don't need to rate the names and know what they mean and know about the literature and whether they're biblical names or not. The data kind of tells you by itself. So it's a nice
I would
approach.
question a little bit your across time, because some of the factors that influence naming practices have changed. So, for example, when Mickey Mouse was out, there was a number of names that were Donald, based on Nickerson's work. Everybody was wanting to name their kids after the duck.
It'll mean something different today.
And it meant something different when I started before it was a Donald. You had Donald and one. I go, well, wait a minute, that's 1930. Wait till 50 and 60.
So, I agree 100%.
But there's one other one, and that is the tendency of certain groups, like the African Americans, to create their names. So LaTanya and Lakeisha, and people just come up with new names. That are just individual and maybe harder to link to expected fertility. But I'm just those are a little noisier cultural infusion that may not. And also, women are not keeping their name or changing their last name. So your fixed effects would have, like Noreen's example, wouldn't fit your fixed effect story.
The second one aside, but why do I say this works over time? I'm not saying that you calculate the scores for 1850 and it works over time. I'm saying any time period you give me, I can calculate these scores. The abstract method of having a test, a training and a test, I can do for every time, for every group. You can customize it. For all the things you think that matter, you can use this generic algorithm for, is what I'm saying. I'm not saying you want to use the scores and keep them fixed over time.
No, I didn't say that, but even I'm just saying the amount of dispersion when you're creating names that are not standard, you're going to have a lot more noise in any period. But that's an empirical question.
So, I think what you're saying is probably tied into how did we compare these coefficients over time? Are they really strictly comparable? And I agree, they're big issues about
Yeah,
how to do that. Okay, and then what's the substantive conclusion here? So the first thing I say is early in the demographic transition, we already see that some parents knew what they were doing about quantity and quality as early as 1850. This is, by the way, before the U.S. demographic transition really starts going fertility transition. So Ansley liked to talk about the calculus of conscious choice, and you don't really need an innovation that now people can choose. Instead, what happens is you have a choice that is in the population that more people are choosing to make. So you're making kind of a subtle distinction. Maybe that's not true. Maybe only some of the people knew that the choice was there. But I'm kind of assuming that everybody does, and some people are choosing it, some are not. And what we kind of find most surprising about this is that when we read these simple fertility models where people have a plan and then they just have that many kids, and you read Gary Becker and you see quantity, quality, trade-off, when does this happen? It's clear that if he's not talking about once you have more kids, you can afford to spend less on them. Or if you can, that's not what he's talking. He's talking about a simultaneous endogenous decision that you make ex ante. Well, that model seems to work, even though there's been decades of adding dynamic changes and all this kind of stuff. This model seems to work. Now, those models may add something to it, but this model is not false of people having some plan, and they tend to stick with it. Okay, so the bottom line here, I suppose, in the sociological or broad social science terms, is that we see this use of microdata as a way to emphasize people making decisions, human agency, not determinism. So we have intentional parenting having a long history. Well, that's not very good for the theory of there being some brand new idea. And it's more that people are activating the idea that the idea is being introduced. And we see people in the same situation. Admittedly, our controls are not wonderful, but let's just pretend we accept that the controls are working. Choosing very different things. Well, that's not very good for the people who say, "Oh, we're just responding." So we really need individual heterogeneity and individual choice, and obviously we need some of both of these theories. And I think the real contribution of this paper is that it kind of pushes us out of this innovation versus adaptation type of framework towards questions like, well, why is it that some people have these preferences for quantity over quality? We get that. Or how, probably these preferences changed over time and spread across the population. Well, how did those preferences themselves change? So I think that's the kind of direction that we want to go. So we've had some questions, but we still have 5 minutes. So.